Okay, good evening all. Now we are moving to the second session of day 2, Aicte-Atal online FTP on emerging trends in electric vehicle ecosystem, power electronics, AI and sustainable mobility. We have with us Dr. Aicte Kumar, Assistant Professor of NIT Partner. Aicte sir.
Yeah, I am here. Am I audible?
Yeah. Okay.
When
So
shall we
we
start?
are
Okay.
So
Timing
we are
is from
moving-
7:40 over. Or we can
Hello,
start.
sir. Oh,
Yeah.
okay. Sir, so we are moving to the official welcoming ceremony for the resource person. So over to you, Parvati. Parvati is there?
Okay, ma'am. Yes, ma'am.
Okay.
So, good evening, everyone. It is an honor to introduce today's resource person, Dr. Aicte Kumar, Assistant Professor in the Department of Electrical Engineering at the National Institute of Technology, Patna. Dr. Kumar has been actively engaged in research since 2014 in the fields of renewable energy, electric vehicles, and semiconductor devices, with applications ranging from memory and solar cells to biosensors and power electronics. His outstanding research profile includes 38 SCI Index Journal paper, 6 patents, of which 4 are granted and 2 are published, along with 12 international and 24 national conference papers and 11 book chapters. He has successfully guided PhD scholars with two these already submitted under his supervision and is currently leading a DST sponsored research project worth 29 lakhs. Dr. Kumar earned his BTech in Electrical Engineering from IIT Varanasi, followed by his PhD from IIT Indore. He also pursued postdoctoral research at the University of Utah, USA, and IIT Kanpur, a recipient of prestigious CSIR Research Fellowship from the Government of India. He has also been honored with several research awards, including Best Presentation Awards and International Travel Support from DST and CSIR. In addition, Dr. Kumar holds multiple professional certificates such as SCJP, CCNA, CCNP, and ACP, reflecting his wide ranging expertise. We are truly privileged to have him with us today. Please join me in extending a warm welcome to Dr. Aicte Kumar.
Yeah. Thank you. Thank you for the introduction. Okay. Shall I share my screen now?
Okay, sir.
Okay. Is it visible?
Yes, sir, it's visible.
Okay. Okay. So to start with the topic today, okay. So I hope you are having a good time in this FDP actually, and I'm very thankful that I have been invited in this FDP for sharing my my thoughts and my works here. Okay, in this FDP. So today I will be talking about electric vehicles, one of the aspects of electric vehicle, which is vehicular dynamics and some aspects of energy storage systems. Okay, so electric vehicle, I'm sure you are much aware of it now because it's the second day of the session. Okay, so some of the basic things I will skip. But of course, to talk about electric vehicles, why it is important. So electric vehicle, since we are in the era where we are talking about clean energy. We are talking about those form of energy which can be sustainable. Okay, when I say sustainable means it can be used for my use but it shall be there in the future as well. So it shall be there in the future generations as well. It's not limited only to my use. Okay, so that's why we talk about sustainable technologies. Okay, we are looking for sustainable technologies. Okay, so that is the idea of the electric vehicle. Okay, so one of the aspect of electric vehicle is like it participates in a in that aspect of technology where it is eco-friendly. Okay, so like I will not say that all the components that are being utilized in the electric vehicle are eco-friendly, but apparently some major aspect which through which this electric the currently the vehicles which is in the form of like the traditional vehicles which has been in the form of IC engines. Okay, so internal combustion engines. So to talk about internal combustion engines, is the whatever the conventional vehicles right now we have been using, had that is like mostly that is IC engine based vehicles. So internal combustion engine based vehicles where petrol or diesel is converted into useful work. Okay, so there the two problems as the source that is being utilized for conversion of the energy is non-renewable, and the second aspect is that however clean we try to make it. Okay, however like government makes policies, makes amendments, makes try to execute that. Okay, like it's kind of whatever the vehicles that you use that is pollution free, we have to get our pollution certificate timely. Okay, that's all the things the government can do, but we have to look towards solutions which can be at which can be which will not be involving this conversion of fuel from this petrol diesel to petrol diesel to like mechanical energy. Why not we look for the certain technology where we can get clean energy. Okay, so like clean energy means clean energy if we can have the energy in the form directly in the form of electricity, and that electricity is being utilized for running a motor, and that running a motor is with the basic aspect of any electric vehicle. So it is being, if energy conversion is being done in this way, it will be more eco-friendly. Okay, so that is the idea of electric vehicles. Okay, so to talk about the history of electric vehicles, some aspect that I will talk about of electric vehicles in the aspect in the history how this electric vehicles was there. Okay, and why at all we not in the it succeeded in the history. Okay, so if we talk about the history of the electric vehicles, okay, so it is not the case that it was not there in the history, because as an electrical engineer we are very much aware that okay, whatever the DC and AC, they are two forms of electrical power. Okay, DC direct current or alternating current. So to talk about DC and AC, we know that DC has arrived earlier as compared to AC. AC primarily we credit Tesla for this AC, and DC was already there. So since DC was there, DC machines were there, so DC motors were there, so and like batteries were there. So why at all this electric vehicle did not flourish at that time? Okay, so some of the aspect that was there, that the infrastructure that was there at that time. Okay, so I'm talking about the era of 1900 around. So infrastructure at that time was not much prepared for introduction of this technology. Okay, so this era was not prepared, that infrastructure, whatever the infrastructure that was there, roads were not at all that good. And even if we talk about metro cities, if the roads are good, it was not the case that electricity was available everywhere. Maybe in the metro cities electricity will be available, but if we talk about other areas, electrical infrastructure was not good, road infrastructure was not good. So these were the basic barriers that was there at that time. Now at that time they had an option of going towards like why not choose, why they opted for this IC engine based vehicle or internal combustion engine based vehicles. The reason was to deal with the petrol and diesel was comparatively easy. They identified a large bulk of petrol and diesel at that time, and they thought that maybe instead of getting electricity everywhere, it was much easier to store petrol or diesel in a remote place in the form of like petrol pump that I usually see around us. So you can have a petrol pump in a remote area, and that petrol pump will be serving the petrol and diesel, and all the IC engines can be running in that area. Okay, even if that is a remote place. Okay, even if that area is having not good road infrastructure, it is not having electrical infrastructure, it is not having electricity. So in that way, IC engine was more friendly, well, in terms of market. Okay, so if you talk about the bulk of the technology being to be utilized by society, okay, it was more friendly to go for this IC engine based vehicle. Okay, that's why they opted for IC engine based vehicle. Okay, and we credit a lot to like. This electric vehicle, at that time, if at all IC engine based vehicle have not been there, yeah, if the idea of electric vehicle would have flourished, so maybe the picture would have been entirely very much different. Okay, so it was you will see in the history the electric vehicles were there in different forms. You can see in the picture here as well, they have been utilizing in the same form that the today we use e-rickshaw. Okay, so they have been utilizing some batteries. They had replaced those horses with this batteries and DC motors, and they have made this electric vehicles at that time as well. So I'm talking about the era of 1990s. Okay, so there are different examples. Okay, so at that time, so in the literature, if you go, so they say that there is, even if they talk about that in around 1850s as well, the electric vehicles were there in 1900 as well, 1910, 20. So like electric, it was not there. The electric vehicle was not there. Electric vehicle was there, but market was more, or if you talk about the society was more friendly towards being using IC engine based vehicle. That's why IC engine based vehicle flourished a lot at compared to electric vehicles. So if we talk about electric vehicles, why electric vehicles? Of course, as I talked about, renewable sources being utilized a lot in the IC engine based vehicles and declining oil reserves. They have impelled us to go towards electric vehicles. Okay, and all those greenhouse emissions, the global warming, and all those rules. I do believe that global warming and greenhouse emissions, those are not only the factors that actually determine any technology to be utilized by human. Okay, it's not that the humans are they will be they will be caring for environment just to use a new technology if that is not pocket friendly. Okay, so that is why the idea of that is why the intervention of government becomes very crucial in that case, because any technology which is new, that if it has to be introduced in a society, that will not be as pocket friendly as compared to existing or whatever the technology which is running currently. Okay, so then there are many policies that are made by the government, and through which electric vehicle are being made very pocket friendly. Okay, there are multiple subsidies. There are different kind of different funds that are being utilized are being provided by government to set up industries. Okay, so there are different, if you go towards, if you whatever state that you belong to, you just look just put in the Google that what is the electric vehicle policy of Uttar Pradesh, or what is the electric vehicle policy of Tamil Nadu. Okay, so there are different guidelines that has been given by center for two different states, and accordingly they are they have been making certain policies which is friendly to that state. Okay, so in that way they have been proceeding towards adopting this electric vehicle into technology. Okay, now to talk about electric vehicle, if I say electric vehicle, the vehicle that will be run by electricity, that is the idea of electric vehicle. It has to be run by electricity. That is the very basic very basic definition of electric vehicle. Okay, so it can be anything. It can run. It can be running on a rail. It can be running on road. It can be a rail vehicle. It can be electric boat. It can be underwater vessels. It can be an aircraft. Whatever it is, if it is running by electricity, you can say that it is an electric vehicle. Okay. So now, why this idea of HEV, hybrid electric vehicle, that have jumped just now. Okay, so see, the idea of hybrid electric vehicle is when things started again, when the history, as I told you, that at that time IC engine based vehicle was more friendly to be utilized. Okay, so in the again when they in the in the era of 2000 around, when they started thinking about adopting electric vehicle again, working towards electric vehicle again, then the very common way in which electric vehicle can be utilized again was to, since they had an 150 years of comfort, many kind of inventions with so much of technology and being flourished by different research and scientists being involved in this area. Okay, so that's why what they opt for is that why not leave why should we leave that comfort? Okay, why not go with a hybrid way? Okay, so that's why they started the things in the hybrid way. Okay, so when I say hybrid electric vehicle, what I mean is the vehicle will be one of the sources of running that vehicle will be electricity. So electric vehicle will be there, but besides electric vehicle, there will be another energy source. Okay, so energy source, the another energy source can be, it can be the vehicle can be having a part which is which is related to IC engine based. Okay, so both IC engine based vehicle and electric vehicle, pure electric vehicle, both are combined, and then you can say that it is an hybrid electric vehicle. Okay, so basically it has to be have one or more energy storage unit, or you can say energy conversion units. Okay, so energy storage unit, the very basic example of energy storage in a case of electric vehicle is a battery. Okay, so that is the idea of a hybrid electric vehicle. An advantage of a hybrid electric vehicle is that it will be having good parts of both like gasoline based vehicles, that is IC engine based vehicles, and electric vehicles. So the advantage will be the range will become higher. So when I say range, by the range what I mean is like the range of any vehicle is what is the what is the number of kilometers that it can cover when it is fully charged. Okay, and it is fully, when I say fully charged, not only the battery is fully charged, but petrol tank is also fully charged. Okay, so in that way, since we have now we have a privilege of having an extra battery in a hybrid electric vehicle. So beside petrol tank, you have energy storage in the form of battery as well. Okay, so that's why the range of the vehicle increases. Okay, now hybrid electric vehicle, it will be it can operate more efficiently. Okay, because we can switch between two vehicles. Okay, now in some of the, in some part of the journey, like whenever you use a motor vehicle. Okay, so there are different trends when you utilize a motor vehicle. Okay, when you start a vehicle. Okay, and now when a vehicle is running on a slant road, when a vehicle is running on a plain road, when a vehicle is running on a road that is not very good. Okay, so there are different journeys. Okay, in which there are there are different different amount of energy which is being spent. Okay, now if we say, if we can switch between two systems in such a way that we don't have to be dependent on one of the system which is which may be useful in one way, but maybe what I try to mean is see, when you start a vehicle, when you start any motor vehicle. Okay, maybe you need to have a very large amount of power or energy. Okay, maybe at that time you can switch towards, if your electric vehicle is not going to give you that energy or that amount of power, you can switch to the IC engine based vehicle. Now when you are in a driving cycle where your motor vehicle is running on a plain road. Okay, then you can switch on electric vehicle. Why? Because you don't need very large amount of power, because the road is good and the road is not slant, and it's a plain road. So in that way, the fuel efficiency will increase. Okay, so then ultimately you will be having an option of moving to switching between two different forms of vehicle running into two modes. Okay, that's why this hybrid electric vehicle is more friendly. Okay, now we talk about if we talk about this hybrid electric vehicle or where the vehicle is like when I was talking about the scenarios, okay, when a vehicle is running, okay, there can be two or three scenarios. One of the scenario where the speed is low, okay, so when the speed is low, power can be provided by the electric motor using energy supplied by the DC battery, okay. So where the speed is low, why we can utilize the electric motor to supply that energy, okay, and by the DC battery. Now the second scenario where the braking is there, what you can do is like the whatever the kinetic energy of this vehicle is there, okay, you can just convert it into electrical energy and store into a battery, okay. That is the concept of regenerative braking. So with this idea of regenerative braking, this hybrid electric vehicle actually started. So idea of hybrid regenerative braking is your braking usually when you brake your vehicle, what happens? So when you brake your vehicle, it whatever the amount of energy that was there in the form of the mechanical energy, that will be actually wasted, okay. If we have been using a bicycle, okay, so usually bicycle or motorbikes, okay, so usually we don't have access to four wheelers where how the brakes looks and all those things. That's why I take an example of bicycles. So bicycles we have all used, okay. So bicycle, we have a brake shoe there in the bicycle. When we apply brakes, that whatever the amount of mechanical energy that is there in this cycle, your bicycle, okay, that is converted into a heat form, and that heat actually affects the material in the brake shoe, okay. So that's why you see that with constant use, that material deteriorates, okay, and brake shoe you have to replace it maybe after 3 or 4 months or whatever time, okay. So what I try to mean is that whatever the energy that was there, that was being wasted. Now why not use that amount of mechanical energy which is otherwise being will be wasted, okay. That amount of energy can be utilized to just think of that. You can utilize a generator, and just that mechanical energy will run that generator, and you will get you good amount of charges, okay, and that those charges will be stored in a battery, okay. So charges and a current, so they are related in the form of, like, see, when I say charge, okay, when I say current, the difference is that the charges, if it is running at constant rate, okay, that's what you say current, okay. And battery does not provide you only current, okay. Battery provides you charges, okay. Battery is going to store charges for you. Battery is going to give charges to you, okay. So now the third scenario is where the high speed is there. During the high speed, power can be provided by IC engine, electric motor, both, okay, by a generator. So generator can also charge battery during high speed. So there are different scenarios in which those hybrid electric vehicles will be have an advantage as compared to a pure electric vehicle or pure IC engine based vehicle, okay. So as I told you that some of the advantages of hybrid electric vehicles are there, that they have an option of regenerative braking, fuel efficiency increases, emissions decreases, they cut emissions of global warming pollutants, okay. Then they reduce the dependency on the fossil fuels, and many other advantages which are there for the hybrid engine vehicles as compared to the conventional engines, okay. Now to talk about the basic components of a hybrid electric vehicles, okay. So basic components in a hybrid electric vehicle will be electric motors, whatever the electrical energy storage systems are there, some hybrid power units. So when I say hybrid power units, so if it is a hybrid electric vehicle, so maybe it can have an option of IC engine, okay. So and then transmission which will be actually moving the whatever the traction that is being involved in moving that vehicle, that traction will get the mechanical energy through this transmission, okay. So battery, generator, electric motors, and all those things are there. Electric motors we are all aware of how the electric motors work, okay. Now if we talk about the energy storage systems, okay. So basic energy storage system for a electric vehicle that we generally discuss is a battery, okay. Now with the battery, as I told you, that a battery is going to store charge for you. In the same way that a petrol tank is going to store the petrol for you, or a water tank is going to store water for you. The battery is going to store charges for you. Okay. Now that charges, if they move at a constant rate, okay, across a cross section area, okay, so in that way you get a current. Okay, when you have a constant voltage around 2 points, then charges start moving through a cross section at constant rate, and that's how the current comes. But if you talk about if you talk about batteries is there to store charges for you. Okay, so that's why we have a parameter of the battery, which we say capacity of a battery. So when I say capacity of battery, that a unit of that capacity is ampere hour. Okay, so ampere hour, if you ampere is like charge by time. Okay, dq by dt, if you multiply it with the time, then you will get charges. Okay, so that is a capacity of a battery, is how much charge it can store. So one if 1 ampere is being provided to a battery, and it takes 1 hour to charge itself, then capacity of that battery is 1 ampere hour. Okay, so that's how that parameter of battery becomes very much important. Okay, so I will be talking about the parameters, some of the parameters of the battery. Okay, so considering the time that I had to okay, so I will be talking about some of the parameters of the battery later. Okay, so the basic parameter that the battery with which we are expecting the battery to change this scenario of electric vehicle is energy density. So when I energy density, what I mean is like a battery is going to store energy for you, but how bulky it is, how much weight it carries. Okay, so the weight of that vehicle and the bulkiness of the vehicle, okay, that is why we try to measure that parameter in the form of energy density. So that has been not made mentioned here, but that is an important parameter of energy density. That is the important parameter of energy density, which actually identifies that why we are looking for lithium ion based battery or more and more evolved battery technology. Okay, so battery that usually we utilize and around us. Okay, so that we are very much aware of lead acid based battery, because we have been using lead acid based battery in our home as well. Okay, so lead acid based battery being utilized through the inverter to power your home when the electricity is not there, but it stores charges when the electricity is there, and it provides you charges and current when the electricity is not there. Okay, so that battery is generally lead acid based battery. Okay, lead acid battery is the most common form of the battery that we usually see. Okay, but we have batteries in our mobile phones, laptops as well. Okay, so that technology is different. Okay, there that is a dry form of battery, and mostly those were the lithium ion based battery. Okay, why I'm talking about this with these technologies right now is because I have to introduce to you vehicle dynamics, where you need to understand that what is the utilization of a battery, what you are expecting with a battery, because that battery is going to give you entire energy for running that vehicle. Okay, and I will show you some calculations how that vehicle dynamics calculations are being done. Okay, some of the forces, what are the forces that are involved in electric vehicle. Okay, so that is the basic aspect of the battery that I tried to explain to you. Lithium ion based battery. When I say lithium ion based battery, why we are looking for lithium ion based battery? Because lithium ion based battery are having more energy density. In the form of volume as well, in the form of mass as well. Okay, so that's why, as compared to lithium and as compared to lead acid based battery, or nickel metal hydride based battery, or nickel cadmium based battery. Okay, so that is why I'm looking for the lithium ion based battery. Okay, now if we talk about the vehicles, okay, there are different vehicle proportion. There can be different configuration. It can be in the series configuration. Okay, where the whatever the engine is there, that generator, battery, and motor and transmission and wheels all are there in the series form. It can be in the parallel configuration, where generator, the battery, and the engine, the IC engine based engines. Those are being utilized in parallelly. Okay, so like maybe for the long trips we can use for go for the engines, and like maybe if the trip is shorter, or maybe as I told you that during the coasting. Okay, during the coasting part of the journey, we can utilize for the electric motors. Okay, so that's how the parallel configuration of the vehicles is being utilized as well. So series configuration are the two parallel configurations. So those are the two basic configurations of the vehicles in which the vehicle propulsion works. Okay, now to talk about vehicle which is purely electric vehicle. Okay, I have been talking about hybrid electric vehicle. Now I'm talking about a vehicle which is purely electric vehicle. Okay, so when I am saying purely electric vehicle, I am trying to say that there is no IC engine based vehicle that is being involved in the design. Okay, now a battery is being utilized with the motor or generator, and through the transmission it is actually providing energy to the transmission, and that's how the vehicle is running. Okay, and when the transmission is actually like when you're trying to break the transmission. Okay, when you're trying to break your vehicle, no, that transmission system will be actually converting the energy from the mechanical energy to electrical energy, and you have a like a generator being utilized in that way, so that that energy, mechanical energy, being restored to the battery. Okay, so that is the idea of a pure electric battery electric vehicle. As I already told you about the hybrid electric vehicle, where the fuels and battery, they are being utilized both. Okay, they can be in series form, and they can be in the parallel form, as I told you earlier. Okay, so it can be in the series form, it can be in a liquid form. Okay, it can be in series form, it can be in the parallel form. Okay, so as I told you earlier, there are some advantages of series form, there are some advantages of parallel forms. Okay, now the other concept of hybrid electric vehicle that we generally see is plug-in hybrid electric vehicle, which is generally seen as PHEV. Okay, so PHEV is a type of vehicle that type of electric vehicle that you can say that can be plugged in or recharged. Okay, that can be plugged in or recharged from like wherever the sockets are there in the wall. We can just plug in and just recharge it. Okay, so there the battery are recharged by plugging it into some external source of electric power. Okay, and whatever the onboard engine and generator that are there with the vehicle, that is being utilized. Okay, so PHEV, if you talk about the PHEV, they have a larger battery as compared to HEV. Okay, and they allow recharging of the battery through like home outlets or at charging stations as well. Okay, so PHEV, if you just if you talk about the PHEV, how largely it is different from HEV, that there will be they will be having much larger battery packs. Okay, the battery packs of the PHEV will be quite larger. Okay, and the size of the battery, that is going to define, as I told you, that the size of the battery or the capacity of the battery, that is going to define the vehicle's range. Okay, so that's why PHEV will be more having generally larger range. Okay, now, there are different configurations of the configuration of different forms of electric vehicles. So we should not get confused. But yeah, broadly, a full electric vehicle. When I say full electric vehicle, then I means that it's a pure electric vehicle. It is running through the batteries only, through the electricity only. I should say. I should not say battery. Okay. Now, plug-in electric vehicle I was already explained to you. PHEV already explained to you. Hybrid electric vehicle already explained to you. So they are being that's the categorization of the electric vehicle. Now I'm coming to the part that I have to discuss today. That is vehicular dynamics. Okay, what is the vehicular dynamics? So first of all, I try to explain to you what is electric vehicle, what is hybrid electric vehicle, what was the idea of hybrid electric vehicle, how it started, how it took the form of hybrid electric vehicle and restarted again in the year of 2000. Okay, as I told you that electric vehicle started again in the form of hybrid electric vehicle. Idea of regenerative braking, I tried to explain to you. Configurations of the hybrid electric vehicle series parallel, and that I tried to explain to you. Okay, now why I'm talking about energy loss in vehicles right now, because I have to move to a topic which is vehicular dynamics. Okay, so there, first of all, you have to understand where the energy is actually utilized. Okay, where the energy of a vehicle is actually utilized. Okay, so now if you take a normal IC engine based vehicle, okay, so just think of that, or you can just imagine that where the energy will be actually utilized, different aspects where the energy will be utilized. Okay, so if it is at a standby, okay, even if it is at a standby, okay, now maybe if your car engine is still on, there will be some accessories which will be utilizing this energy. Maybe the AC is running, maybe some maybe music system that will be running. Okay, now there will be when vehicle will be actually running, okay, there will be some losses during the conversion, okay, because we are trying to convert petrol or diesel into into mechanical form of energy, so there will be some losses. Okay, so there will be some losses in the drivetrain as well. Okay, so but these are the losses which are in general. Okay, it is applicable to all types of vehicles. Okay, now if we try to skip this part, now we come to that part where that will be how that part will be common to both IC engine based vehicle and the electric vehicle. Now to talking about those parts, okay, so there are two aspects. Okay, first aspect of vehicle first of aspect of any vehicle running is you have to understand that what are the forces that a vehicle has to overcome. Okay, now if we talk about any vehicle, okay, so it has to overcome certain forces before it will be start moving. Okay, so first aspect of that force is aerodynamic drag, or I should not say first aspect, it's one of the aspect. Okay, it's the aerodynamic drag. So what is aerodynamic drag actually? Okay, so when I talk about aerodynamic drag, what aerodynamic drag actually means, okay, so see, you have a fluid system around you. You have a which is air. Okay, now imagine that you're running a bicycle on a road. Okay, so you are comfortably running your bicycle on a road. Okay, now imagine that you have to run that bicycle in a swimming pool. Okay, so I think that it will be more difficult to run up your bicycle in the swimming pool. Okay, I'm just giving you a hypothetical situation. Okay, so what I'm trying to mean to you, that fluid system around you that changes, that has a role, that has a significant role upon you. Okay, so that role I'm trying to discuss here. Okay, this aerodynamic force. Okay, what this aerodynamic force actually does is, like, since the fluid system around us is air. Okay, so that's why we are naming it, or we are literally meaning it aerodynamics. Okay, so it is the resistance, or this is a force that is exerted by the air against the forward motion of the vehicle. Okay, so I have to take the example of two-wheeler. That's why I mentioned the two-wheeler, but it is applicable to two-wheeler, four-wheeler, everywhere. Okay, so whenever the vehicle moves, it encounters the air resistance and it acts in the opposite direction, and it opposes the vehicle's forward movement. Okay, so that is why aerodynamic force is that is how aerodynamic force works. Now there are two aspects of the aerodynamic force. Okay, I have not mentioned it here. Okay, but I will just tell you. Okay, see, first aspect is skin friction. Second aspect is shape drag. Okay, skin friction. What is mean by skin friction is like, what the skin of a vehicle is actually affecting the mm, state of fluid system around us. What I try to mean is, like, when a vehicle moves. Okay, when a vehicle moves, maybe whatever the fluid, whatever the air that is enclosed to the vehicle, okay, that will be moving. Maybe that will be moving at the same speed, or maybe relatively very high speed as compared to the air particles which is far away from the vehicle. Okay, so there will be some irregularities in the different layers of the air. Okay, that actually creates a situation that creates a force, that is skin friction. Second part of the aerodynamics is shape drag. Okay, shape drag means the shape of the vehicle has a role on shape of the vehicle has a role on how much aerodynamic force will be acting upon it. Okay, so that's why you usually see that there are different the vehicles have a certain shapes. Okay, you have a bus will be that there in a certain shapes. Smaller vehicles, it has very flamboyant shapes. Okay, they can be in the sedan shape, they can be in the omni cars that you have seen. Okay, maybe you have seen different many premium version of the vehicles. So shape is actually because the whatever the frontal area of the vehicle that will be exposed to the air when the vehicle will be moving. Okay, so because of the how that frontal area will be looking for what is the shape of the vehicle, that will be actually very important for that for considering the aerodynamic force. Okay, so that see. This is what I try to mean here. So, if you talk about the aerodynamic drag, what I try to mean is the density of fluid system. As I told you that with the example of a bicycle being driven in an air, bicycle being driven in a swimming pool, I try to mean this part: density of the fluid system has an important role in aerodynamic drag. Second part is frontal area of the vehicle. So frontal area means what is the area of the vehicle that is exposed, okay, to the forward motion. Okay, whatever the forward like fluid system that is there. Okay, so that is the frontal area of the vehicle. Third part is coefficient of aerodynamic drag. Okay, so I will come to the aerodynamic drag later. Okay, now the fourth part is velocity of the vehicle. Okay, so when the vehicle is moving, okay, with respect to wind, what is the relative, what is the velocity of it. Okay, so that is for the aerodynamic drag will be square in proportion to the relative velocity. Okay, now if we talk about the coefficient of coefficient of aerodynamic drag will be taking care of other aspects which are not shown in this formula. Okay, so the shape drag, as I told you, as I was telling you, that shape will be having certain roles. Okay, they will be having certain roles in the aerodynamic force as well. Okay, so that part will be taken care of by coefficient of aerodynamic drag. So what you can expect that for different vehicles, this coefficient of aerodynamic drag will be defined differently. Okay, so for rail system it will be different, for maybe for buses it will be different, for different kind of vehicles. I was trying to mean this part. Okay, so maybe if you have an open convertible car, maybe the aerodynamic resistance can be in the range of zero point 0.5 to zero point 0.7. If you have a maybe ponton body, okay, or a wedge shape body, okay, so maybe this coefficient of aerodynamic drag will reduce, so it can go in the range of zero point 0.3 to zero point 0.4 or zero point 0.4 to zero point 0.5. Okay, if it has having some K-shaped kind of or it has small breakaway section. Okay, so it can this coefficient can reduce drastically, so it can go in to the value of 0.23. Okay, now if we talk about the zero trucks, road trains, okay, they have the values in the range of zero point 0.8 to 1.5. Buses in the range of zero point 0.6 to zero point 0.7. Motorcycles 0.6 to 0.7. The certain streamlined buses, they have in the range of 0.3 to 0.4. So what you can see here is like these coefficients are maintained in such a way, the shapes are maintained in such a way that this coefficient is having different depending on the type of vehicle that you are trying to utilize, this value will be different. Okay, so where the smaller vehicle which has to carry maybe 2 or 3 or 4 passengers or 5 passengers, you can deal with this high range of this aerodynamic resistance, which is 0.5, 0.6, or 0.7. But when you have to deal with a vehicle which is a truck, which is a bus, which can be a road train, okay, which can be a train. Okay, so there the number of passengers is high, so you have to you have to have a aerodynamic this coefficient small and small. Okay, that's why the shape is of those trains, buses are that in this different way. You don't have much privilege to have the shapes of different shapes that I discussed to you earlier, like K-shaped, van shape, ponton shapes, open convertible shapes. So those options will not be there. Those options will be limited there. Okay, so this is the role of aerodynamic drag. Okay, so skin friction already told you that shape drag and like what the shape drag means and skin friction means as I already told you. Okay, that part. Okay, so now I just take an example of this. This is from one of the papers that I worked that we worked in our lab actually. So there we took an example of a two-wheeler scooter, and another paper we have taken an example of electric vehicle, which is a four-wheeler. Okay, so we try to utilize whatever the forces that are whatever the forces that are there, which will be opposing a vehicle, and we try to calculate that what is the amount of force or that we have to be that have to be worked upon that vehicle to run, first of all, to overcome those forces. Okay, so whatever the forces they were there, like aerodynamic drag or rolling resistance. I missed the rolling resistance, I missed road grade, I will tell to you. But whatever the forces which a vehicle has to oppose, first of all it has to oppose those forces, then you have to make that vehicle running. Okay, so that's why this is one of the another literal term, that is tractive effort. Okay, so tractive effort is going to deal with that force. Okay, so tractive effort will be taking care that what is the amount of force that will be actually working on a vehicle to make that vehicle running. Okay, so first of all it will overcome those forces, then it will have that sufficient amount of value so that it can overcome it, and not only overcome it but also it can make the vehicle running. Okay, so this is what I was talking about. Okay, see see if you can see this formula, FTE is tractive effort, and it is taking care of all those forces. Okay, so rolling resistance force, aerodynamic force, hill climbing force, okay, linear acceleration, angular acceleration. Okay, so all those, because when a vehicle will be moving, it will be, see, if when a vehicle is moving actually. Okay, so I missed. I have not discussed this part. So first of all, I should discuss other forces, and then I will come back to that equation again. Okay. So first thing is another aspect of the force is rolling resistance force. Okay. So rolling resistance force is, see, we know what a resistance is. We know the significance of a resistance. Okay, for all of us. Okay. So what is the difference between a vehicle running and a V walking? Okay, the difference between V walking and a vehicle running is like we will walk maybe in a translatory motion, linear motion. Okay, there will be no rotation involved. Okay, but in a case of vehicle, okay, the wheels actually rotate around axles. Okay, so wheels, as they move around axles, and the whole vehicle rolls. The whole vehicle rolls on the road, and that's how the vehicle runs on the road. Okay, so that's how the rolling. That's how the vehicle runs on on the road. Okay, so what is the amount of resistance force that vehicle has to overcome when it is rolling over the road? That is a rolling resistance force. Okay, that will be influenced by various factors like tire type, road condition, load on the vehicle, and all those things. Okay, now the rolling resistance, like the settings, the besides the rolling resistance, the second aspect is hill climbing force. So what hill climbing force means is like, see, as I shown to you this, I shown you this situation where the our scooty or the two wheeler is there on the slant road. The slant road is having an angle theta. Okay, so see, when you are on a slant road, when you are walking on a slant road, maybe we have to make extra effort. Why do you need to make an extra effort? Because the one part of your weight, that is mg sine theta, works against you, and it works parallel to the road, and it works against you, and that's why you have to overcome that component of the force as well when you have to walk around a slant road. Okay, so the same is applicable to the vehicle as well. So this force is being termed as a hill climbing force here. Okay, so hill climbing force will be dependent on the what is the inclination of the road. Okay, so in this force, not only the force, not only the mass of passengers will be considered, but at the same time the mass of the vehicle will be considered. Okay, so that will actually in total will count for the what is the hill climbing force for any vehicle. Okay, so Now we have a situation where you have drawing resistance force calculations done, running force resistance done. Now you are now also understand what is the influence what is of the road grade. Okay, road grade means what is the slantness of the road. Okay, so all those forces are in combined are termed as a road load. So it is not that you will see this literal term everywhere. Maybe in some of the books you will not be seeing this term, but the basic aspects of these forces will be there. Okay, aerodynamic force will be there, lowering resistance force will be there. This hill climbing force will be mentioned in the different forms. There will be they will say somewhere gradient force. They will somewhere say somewhere road load even. Okay, so but that is mg sin theta. Okay, so in physics through the whatever the literal terms may be different, but the basic idea is the same. Okay, so that is the basic idea that I just try to discuss to you. Okay, so that is the total road load. Now linear acceleration, what is the linear acceleration, angular acceleration that is being involved with that vehicle. Okay, when a vehicle moves, okay, the vehicle will move in a translatory motion. The wheels will be moving will actually rotate around the axis. Okay, so both the linear and angular motions are involved. So linear acceleration force and angular acceleration force both are involved. Okay, so like you have to consider linear acceleration force and angular acceleration force both. Okay, so that's why you see in this formula we have tried to we have to count for all those forces: rolling resistance force, aerodynamic force, hill climbing force, linear acceleration force, and angular acceleration force. We try to put everything here. Now that's how we try to calculate the tractive effort. Okay, now if we have to know that what is the amount of what is the amount of amount of force that has to be applied, that so that a vehicle will not only move but at the same time it will be overcoming all those forces. Okay, follow the Newton's second law for the second of the vehicle. Okay, for any vehicle, for any body. Okay, so where the acceleration is defined, dv by dt is equal to total forces which will be acting to make a vehicle running against minus whatever the opposing forces are there, divided by the mass of the vehicle. Okay, so whatever the total mass is there. Okay, so that's how we will be able to calculate that what will be the acceleration of the vehicle. Okay, so that's how we try to calculate the forces that are acting on the vehicle and the acceleration of the vehicle. Okay, so in this way, these are the basic aspects of the vehicles which are being vehicle dynamics, which I try to discuss to you very briefly. Okay, here. Okay, so these are the ways in which we, first of all, why we are trying to discuss these things here, because you have to understand that what are the forces that a vehicle has to overcome. When you know the forces, you will be able to know that like what is the amount of energy a vehicle has to vehicle will require for it to move. Okay, because what is the difference between a force and energy? Energy is going to like when you push a body and you are able to displace it. That's how why you are displacing. Why are you able to displace it? Because you are putting some energy. Okay, you are using your energy. You are transforming that energy into a mechanical energy, and the body is being pushed. Okay, so uh, if you know that what are the forces that are involved, if you know that what is the distance displacement that is coming, okay, you will be able to understand that what is the energy that is being will be utilized. Now in that case, in this situation we come back to the situation. So in this situation we'll be knowing that maybe that how what is the different energy requirement of different parts or different aspects in a vehicles. Okay, so different whatever the different sections, whatever different parts, different forms in which energy is being utilized in a vehicle. So now you can see this is not only applicable to IC engine based vehicle. It is also applicable to electric vehicle. Okay, the only thing difference will be that here in IC engine-based vehicle, that energy will be supplied by a fuel tank that will be supplied by IC engine-based vehicle. Okay, now in case of electric vehicle, this whole idea of energy, being utilized, energy being has to be utilized. That energy, amount of energy that will be required, that has to be supplied by a battery. Okay, that's why I try to discuss to you a battery first, the basic concept of a battery. Try to discuss to you. Okay, so battery will be actually taking care of all these different energies. Okay, all these different energies have to be covered, have to be overcome by the battery, and this is why the energy storage becomes very much important. Okay, so that's why when I was trying to discuss to you a battery. Okay, so it's not that the battery is the only energy storage system. There are different other energy storage systems as well, but battery is the primary energy storage system in a electric vehicles. Okay, it can be lithium ion based battery, it can be nickel metal hydride based battery, it can be nickel cadmium based battery, it can be a lead acid based battery. Okay, but this battery is going to store charges for you. Okay, now there are other energy storage systems. One of the energy storage system is ultra capacitor. Okay, so we know what is the difference between a capacitor and a battery. So if we talk about a battery, if we talk about a capacitor, okay, the difference is, like, capacitor is also going to store energy for you, battery is also going to store energy for you, but you cannot rely on capacitor to it will be providing you energy at a constant rate. Okay, because a capacitor is maybe it will be it will be useful in those cases where you maybe needing large amount of energy in a small span of time. Okay, so maybe in that case capacitors will be useful. So what are those situations where this ultra capacitor can be utilized? Those situations may be that maybe you have to pass a hurdle, maybe you have to just make your vehicle running on a slant road, maybe you have to start your vehicle. So at those situations where you maybe needing a large amount of energy. Okay, so when you're starting a vehicle, you're making your vehicle which was earlier in the state of inertia to state of motion. Okay, so maybe in those situations ultra capacitor will be utilized. Now the other form of energy storage system is a flywheel. Okay, so flywheel, I've not shown it here. Okay, so flywheel, I will just make you I will maybe I'm sharing a YouTube video like where this flywheel is actually showing how this flywheel actually looks. Okay, so I'm not showing it here, but I tell to you what is the flywheel, what is the basic principle of flywheel is. Okay, the principle of flywheel is in the same principle that I earlier tried to explain to you, that the mechanical energy, okay, mechanical energy of a vehicle, okay, that mechanical energy of vehicle, if it is transformed, okay, I tried to explain to you at that time regenerative braking, where that mechanical energy was being transformed into electrical energy. Now, in the case of flywheel, the mechanical energy is not transformed into another form. That amount of that motion, okay, that motion of the wheels, that can be that can be utilized, that can be stored, that motion can be stored. Okay, that motion can be stored in the form of mechanical energy. Okay, what I try to mean is that it's not that, so suppose you have a wheel running. Okay, now you have a system where that motion, that amount of motion that the that wheel is running at certain rpm, that you can store that. So you have a system where it can just keep that movement, keep that running stage to storing, because you have a very ideal system where the stage wastage during the mechanical motion is less. Okay, so they have made that system in some ways that it is a wheel that is flying. Okay, that's why you term it as a flywheels. Okay, so flywheel is another form of the energy storage system that is being looked forward for. And other aspect, but with the time limitation, I will not be able to cover that. But other aspect of the energy storage system is a fuel cell. Okay, so fuel cell is I have not put it in here. Okay, I'll just see if I can. Some slides are there, or I will just explain to you those things. Okay, so energy density. So the fly is so okay. Fuel cell is there. Okay, so fuel cell. The one other aspect of the energy storage system is a fuel cell. So what a fuel cell is actually, okay, so fuel cell is you can think of a fuel cell is if you have done the electrolysis experiment during your 9th, okay, so in there what you used to do, you used to had a battery, okay, you used to had a battery, okay, and this battery used to supply energy to that closed box where the electrolyte and node cathode and all those things were there. Now when you are supplying battery to that electrolyte, okay, electrolysis used to happen, okay, and whatever the acid that you generally utilize there, okay, now at the anode and the two anode and the cathode, the hydrogen and oxygen, those are released, okay, so that is the electrolysis of water that I'm trying to explain to you, that trying to discuss to you, electrolysis of water experiment, where S2 breaks into hydrogen and oxygen. Okay. Now, a fuel cell is just reverse of this electrolysis experiment that we have done in our in our labs. Okay. There, the hydrogen and oxygen, they will be combining together, and byproduct will be water, but it will be releasing a large amount of energy. Okay, so that energy will be utilized in the form of electricity, okay, and that electricity will be utilized to run a vehicle, okay. That is the idea of a fuel cell, that is the basic idea of a fuel cell that I tried to explain to you in a very very simple way, okay. So we have generally in our class we try to discuss all the aspects in a very broad manner, okay, but considering the time limitation, okay, I will try to maybe some other lecture will try to discuss this fuel cell, maybe I'll show you how this fuel cell works and all those things in a different and in a way much extensive way. So I hope I am on time. Okay, so I have been trying. Okay, one aspect. Okay, of vehicle that I tried to discuss to you earlier. Okay, which was different configurations of the vehicle, okay, series and parallel configuration of the vehicle and hybrid engine based vehicle, okay, that is applicable to the fuel cell car as well, okay. So there as well you have an option of series hybrid and parallel hybrid vehicles, okay, because fuel cell you can just think of that it's a electric vehicle which is being run by a fuel cell, okay. So in this way I try to explain to you the certain aspects, okay, of the vehicle, okay, of the electric vehicle, okay. I hope I've been able to deliver to you something which can be utilized by you guys for your this aspect of the different aspect of electric vehicle that you are trying to understand through this FDP, okay. And maybe some other session we can discuss about how this simulation, some simulation that I can show to you how these things can be we try to implement this vehicle dynamics to make a vehicle running, okay. And we generally what we do in our classes is like we try to consider all those forces, we try to do the calculation of the forces, and we take a motor that is some, it can be a BLDC motor, it can be a PMSM motor, SRM motor, and we utilize the battery and we do the simulations and it show that how this energy is being being given by that, what is the number, what is the calculation, what are the calculations involved in just calculating different forces that are there in a vehicular dynamics, and how this battery is going to cope up with all those forces and at the same time provide enough tractive effort that the vehicle can run, okay. So I hope this has been useful to those you guys, okay. And okay, so if something is there you can ask me on you it's this is my contact ID as well. You can, if you have questions, you can mail me on this email ID, okay. And you can maybe on WhatsApp me as well if you have any questions, and if you have some questions right now you can discuss.
Thank you, sir, for your enlightening session. We shall now proceed to the Q&A segment. If there are any queries or points for discussion, they may kindly put forward now.
Yeah, if something is there, you can ask me or you can contact me on my email ID. You can put your questions there. Okay. On my email ID, this is my email ID, that is amitesh.double@nitp.ac.in. And this is my contact detail. You can put your questions there. Okay. And ask me if something is there later as well. Okay. So I hope there are no questions. Okay. So, thank you to the team for this invitation. Thank you to the participants for listening me and this very late. Okay, maybe you have been working, maybe you're working somewhere, or maybe you are studying. Okay, so thank you all that you have you have taken out time to understand some aspect of the electric vehicles to this FDP. Okay, and thank you to the organizers for inviting me.
Thank you, sir. As a token of our appreciation, we take this moment for the virtual presentation of a memento to our esteemed speaker. We once again thank you, sir, for your valuable time and insights.
Thank you. Thank you.
This marks the end of the session. You may leave now.